Hi, my name is Bruce Patsey, and I work with Oil-Dri Corporation of America. I am Vice President and General Manager of our Fluids Division. Today, we're here to answer a few questions. Our company produces bleaching clay products, which are used in the fats and oils industry. To my left is David Brooks, and David is the Senior Scientist at our Innovation Center in Vernon Hills, Illinois. And then our moderator today asking a few questions is Frank Filippini. And Frank is a scientist here in Vernon Hills at our Innovation Center. Frank, why don't you take it away?
Sure. Thank you, Bruce. First question today is, what real tangible benefits can oil processors expect when working with Oil-Dri bleaching clay products?
Great question, Frank. We have our company offers a very high level of technical support both in field and at our lab here in Vernon Hills. We have a full line of acid-treated bleaching clay products, and we have a very unique natural bleaching clay that works real well in several different oils. And then we also offer excellent delivery service. So our on-time delivery is outstanding. We have enough capacity at our plant to meet our customers' needs, and keeping plants up and running is very critical. When we take a look at working with these plants, what we do is we go in and work with the operators, and we try to optimize both maybe the temperature, the residence time, and then we're also taking a look at the moisture and the oil flow to make sure that's good. And all that is to try to reduce the use of bleaching clay when we're working with these customers. Our acid clay products, they manage various oils like canola, soy, or sunflower. And we also, our natural clay PureFlow B80 is very unique, and it's the only organic certified bleaching clay in North America today. It also does an excellent job of reducing 3-MCPD esters in deodorized palm oil, and it's sold around the world for that application. Our company has over 40 years of proven reserves and 100 years of known clay reserves, so we're going to be a partner with our companies that we work with for many years in the future. Thanks, Frank.
Thank you, Bruce. You mentioned technical support at the laboratory in Vernon Hills. My question for you, Dave, is what types of support and services does the laboratory provide?
Thanks for asking this question, Frank. The overall focus of our Innovation Center technical service team is to provide product support, to promote customer satisfaction, and to assist in new product development. The analytical capabilities of our lab affords us the ability to fully characterize minerals that come in and oil-based media. Additionally, the Innovation Center is operationally capable to process a given oil through a common set of refining stages to a sub-macro scale, 5,000 grams. We have the ability to perform side-by-side lab service to evaluate performance impact through degumming, bleaching, and deodorization stages. Our technical service requests include anything from a standard ICP evaluation of trace elements or an MCPD assay of a given processed oil to running product performance checks for our customers. Provided we receive enough sample, we can assay and process any given oil in short order and provide a report within a 2-week turnaround time.
Awesome. As a quick follow-up, how do these services translate to value to the end user?
Our technical team is always available to provide exceptional product support to our customers at no cost as they implement our products into their processes. We help mitigate challenges by anticipating our customer needs and collaborating with them to minimize costs and maximize success. The value placed on our services alone is realized directly by current costs of doing outside lab work. Lab assays, especially ones that employ high-end instruments such as GCs or ICPs, they can be priced in the range of $300 to $500 per sample per assay. A simple performance check of trace elements, a common technical service request measuring calcium, magnesium, iron, and phosphorus by ICP, usually on 3 samples including before and after and a starting control, would easily represent a $1,000 value. The value of the technical work we do on behalf of our customers is also realized in the quality and speed in which we can provide information to the customer, specifically to help align product performance with changes in oil quality, or to track down sources of downstream issues, or to provide field test support.
Thank you, Dave. Bruce, over the years you've gained a lot of experience out in the field visiting many refineries. When designing or updating a refinery, what equipment or design elements can help reduce operating costs and bleaching clay use?
That's a great question. You know, Frank, I've been in the industry since the early 90s, and I've been into a lot of refineries. And one of the things I find is that companies that have load cells on their feeders or their day bins have a good chance of measuring the clay well and using less clay in their operation. Anytime you can give control to the operators, they generally will use less clay and it'll be a more efficient operation. We've also seen things like an automatic chlorophyll or colorimeter in line. This again gives the operator a lot of control in terms of how to use their refinery and to make sure that the quality of the oil going out in the yard is in good shape. Silo level monitoring devices are also something I really recommend for companies, especially ones that have small silos. If you get a quality of oil come in that's poor, you can really increase your clay usage and you can get caught short of ordering clay on time. So clay monitoring devices are great, and you can also extend that information to your supplier and they can be a second pair of eyes to keep your silo full. Cavitation pumps are new to the market, and that has been very helpful to help increase yields and lower chemical use in an operation. And then enzyme degumming is another item that we've seen in the industry, and that's helped increase yields as well in oil. From a spent clay standpoint, a lot of companies don't have a system for cooling or quenching the clay, and that's something they should really look into, especially if they're working with unsaturated oils.
Thank you. One final question is what needs do you see for vegetable oil processors in the next 10 years, and what does Oil-Dri have planned for the future?
Great question. You know, adopting new technologies, I think, is something that has to continue, especially at some of these older refineries. So they need to put in cavitation pumps or enzymatic degumming. They need to put new processes in to increase yields and drive profitability at their plants. Other things is they need to keep exploring applications for their end products. We've seen a lot of really unique applications where soybean oil is used in grease today, or it's used to make foam products. So all these higher value opportunities will make their refinery more cost effective to run. Focus on producing low contaminant oils. I know that things like 3-MCPD esters and GEs have been a big issue over the years, but now there's MOSH and MOA, so they're worried about mineral oil getting into the final product. So continuing to focus on that area to make good quality products will be important in the next 10 years. And then managing transportation needs making sure their products get to the end user on time. You know, from Oil-Dri's side, we've seen this renewable diesel business kind of coming at us, and we've done a lot of great lab work here at the Innovation Center, and we've come out with a new product called Metal X, and Metal X is fantastic at removing trace phosphatides and as well as metals from various feedstocks for this industry. So it's a great product. It offers great filtration characteristics, and it reduces any downstream filter fouling as well because it traps well on the filter screens. We're also looking into possibly a new product to help remove chlorophyll a little bit more efficiently, and we're doing some work on 3-MCPD esters with one of our products to see if we can improve its ability to absorb some of the contaminants that form the 3-MCPD ester in deodorized oil. But we're excited about the future, Frank, and I really appreciate the question. Thank you.
Thank you. Thank you, everyone, for joining us today. Bruce and Dave will be here to answer any questions that you have. Thank you.
Hello, we're back here. Hopefully you enjoyed the discussion. We are open for questions. I have a question. The first question for Dave Brooks. Dave, what is your lab approach for understanding the percent of bleaching clay to be used in a lab setting when analyzing a customer or prospective customer's once refined oil that may come into the lab?
Well, it's kind of an interesting experience when we get these unique oils that come into our lab. The first question that we have to ask is uh, what sort of specs we are dealing with. You know, some oils, such as algal oils that we worked with, have had an overload of chlorophyll, and we need to knock that chlorophyll down. There's been used oils of all sorts and types, and what we try to do is shoot for running what we call a bleaching isotherm. We do a down and dirty bleach under controlled conditions as best we can, and look for meeting those target specs. And then once we've got the dosage honed in, we start playing with the variables. And uh, it is a challenge in many cases to try to dial in that unique dosage and combinations of variables. But it's something that we do on a regular basis for our customers that come into us with these unique oils. You know, everything from algal oil to the DDGS corn oil, used oils, waste oils. It's been an interesting ride.
Excellent. I got a follow-up question for you. Dave, how does lab clay dosage relate to in-field clay dosage in a plant setting? So when you're doing your lab work, um, you pick a certain dosage. How does that really compare to the field?
Well, the for researchers in the laboratory, when you talk about translation of what's going on in the lab to the refinery, the holy grail is to get direct relationships. You know, most of the time when we're dealing a lab scenario, we're dealing with a side by side type of research, and not going for direct, dosage, for dosage in the field. Generally, with a lot of the oils, you'll see that you'll have to double a lab dosage to achieve the same level of bleaching or effectiveness that you'd see in a full-fledged refinery. So usually, what we'll come in and we'll do our isotherm, as I mentioned, and we'll pick a dosage and we'll go up 15%, go down 15%, and kind of try to figure out where we're at. Or if it's an oil that we've never worked with before, we'll shoot for a screening test. We'll go for broke with say 5% clay sorbent, and assuming that's probably the high water mark for any refinery to work with at 2.5%. So.
Okay, perfect. Next question's for me, and it says, Bruce, what specific examples do you have of helping an oil processor improve their process and reduce their costs? I won't get into specific names of companies, but we've been in several companies where we take a look at the temperature at which they bleach their oil, and I'll pick two oils, corn oil and palm oil. Those oils sometimes are bleached at too high a temperatures in facilities, and you can generally bleach both oils down around 200 Fahrenheit and get good results. And so we'll go in and when we review that, we'll talk to the processor about lowering that temperature. And in most cases, they can do that. It's not a problem to lower it. Once they do that, they generally save some good money and energy costs because everyone knows you have to heat the oil up in order to process it. So that's one way we've done it. Another way, some companies, when we walk in, they're body feeding DE in with the bleaching clay to get flow rates. And one of the big strengths of our clay is its filtration characteristics. So we're able to tell them to back off on the DE dosage or completely stop it. And they generally find they don't lose any, they can get long, even extended cycle times with our clay, which of course saves them a lot of money in DE use when they're running their processes. So we've done that more than one time in the field. And those are just two ways that we've saved costs for the end user. Dave, another question for you. With regard to, as I've talked about our clays of filtration and the ability to provide very good flow rates, from your side of things and looking at the particle size distributions of our products and that, can you talk a little bit about why our clay is so effective at letting oil pass through it? Um, people can get extended filter cycle times with it.
Well, our filtration properties or characteristics come from our base minerals. And we have a unique mineral base called palygorskite, which is a combination of montmorillonite and attapulgite type minerals. Now, what does this translate to? This is a type of mineral where you have bundles of attapulgite that you kind of like straws that you have propping open cornflakes of montmorillonite type mineral. And this bridging effect and this propping effect allows our clays to be very porous and allows for the oil media or the filter media to go through it at a rapid rate. So these contribute to our filter ability, as well as the fact that we were able to adjust particle size distribution of our powdered products. We can go anywhere from coarse powder to fine powder and achieve good flow characteristics because we control the amount of fines that are present in the end product through our mills and such. So,
okay, perfect. One other question for me is, how do you educate your end users on your products in the field? Today when we make sales calls, of course, we analyze what types of oils they're using, what kind of the specifications that they're using, and then we can make recommendation from our portfolio of products, what product to talk to them about. But the other thing that we offer is a course to educate the operators, and I think it's very effective. It generally takes an hour to an hour and a half. And the goal of the course is really just to do basics on understanding what our mineral does and refining. We go over refining and what affects the bleaching clay and other parts of the process, so that the operator has a general overview of the clays, and they know it's not just dirt that they're putting into their oil, that it has a cost to it, that has a functionality. And it really gives a good baseline for the operators. And most of the times I find that the operators always have very good questions for us, and it turns into a give and take type of discussion. So operator training is something that we provide in the marketplace today, and it's generally well received with our customers in the market. That's about it. I don't see any other questions. Dave, any other comments from you?
Nope. Thank you very much for the opportunity to have this time to discuss it.
Yes, absolutely. Okay. With that, I'd like to bring on and discuss our next speaker today. This is going to be Dr. Van Aert. She's the Director of Research at Ancom Technology, where she manages research projects, facilitates collaboration between engineering, software, and marketing groups, and contributes to new product development from concept through completion. Her published research outputs are focused on method development and optimization, preservation and sensitive food components through active biodegradable packaging, and fundamentals of human perception as it relates to food flavors. In her free time, Marlene enjoys oil painting and trail running. Marlene's going to talk today about isolation of vitamin A, E, D, and cholesterol from food and feed using an automated method.